All right, today is going to be a continuation of what we started yesterday, which is dealing with solving absolute value equations. We're going to be working on that. Now we're going to go to a little bit more complicated one. We're going to work on number 7 over here. So we're going to zoom in. You guys are going to put number 7 down carefully in your journal, and we're going to work on this together. All right? So first step when you're solving an absolute value equation is to make sure that you get this expression right here. You get it all by itself. Well, lucky for us, it is all by itself. So we're good. Okay. Then what we're going to have to do now is this expression right here could technically yield us, all right, there's two things we could plug in right here for it to equal 2p minus 3. So we're going to do a quick review from yesterday. Ready? Quick review from yesterday. If I said the absolute value of x equals 10, there are technically two numbers I could plug in to this inside the absolute value bars that will yield us the answer of 10. Does anybody know one of the answers that you could plug in? 10. You're right, 10. All right. Now there is another answer that we could plug in that would also work. What would that answer be? Negative 10. You're right. Excellent job. All right. Now, what is the definition of absolute value? Basically, what did we say yesterday? It's the distance from what number? The distance from 0 to wherever that number is. So if I'm way over here at a 10, what's the absolute value of a positive 10? 10. What's the absolute value of negative 10? 10. So that's kind of easy, all right? But now we're going to do something a little bit more complicated. We're going to take the absolute value of 2p minus 3. So here's what I'd like you to do. In your journal, could you put a little parentheses around this guy and say, hey, all of this could equal 2p minus 3, or all of this could equal a negative parentheses 2p minus 3. So this could be a plus. This could be a plus, a positive version of this, or it could be a negative version of this. So what I like to do is I like to separate it into two equations. So we're going to have a positive version. Here we go. We're going to put 8 plus p equals, I'm just going to put 2p minus 3. And then I'm going to put 8 plus p can equal a negative, open parentheses, 2p minus 3. Just so you guys know, parentheses matter. Make sure you put things in parentheses when you need to. All right, so there's our two equations we're going to solve. Now at this point, we're just back to algebra 1 right now. We're just solving for a letter. So we're going to start with this guy. All right, so now that we're working on this, we need to make a decision. Where do we want to have all of our variables? Well, since I have two p's over here and one p over here, all I'm going to do is I'm just going to take away a p from this side and take away a p from this side, and 2p minus a p leaves us with 1p. Well, if I put all my variables on the right-hand side, that means I got to move all of my constants to the other side. So I got to add a 3 here, going to add a 3 there. And 8 plus 3 is 11. And it looks like I found one of my answers. I'm going to say p equals 11, and that's one of my answers. Now, we're done with that. We're going to move over here. What are we going to have to do first? We're going to have to distribute. So we have 8 plus p equals negative 2 times p, which is negative 2p. And a negative times a negative equals a positive, so I got to put plus 3. Heh. On this one, we moved everything to the right. But on this one, watch what I'm going to do. I'm actually going to move all of my variables to the left-hand side because for me, it's easier just to add a couple of p's to both sides and keep things positive. So how many p's do I have total over here? If I have 1p and I'm adding 2p's, I have a total of 3p's. got to take away, basically I got to take away this 8 because I got to move everything over to the other side. So put minus 8 here, that zeroes out. I'm going to put minus 8 right there. 3 minus 8. Ooh. 3 minus 8 is negative 5. And then what are we going to divide both sides by? 3. So we're going to divide both sides by 3. So what's our other possible answer? Our other possible answer is negative 5 thirds. So we have 2 answers. All right, now that we have 2 answers, we're going to show you guys how to check those answers. So here was our original equation. So everybody sees we have the absolute value of 8 plus p. And we have 2 answers that we're going to plug in, okay? What's one of the answers we found? What was it? Oops, my bad. Let's check real quick. One of our answers was 11. All right. And what was the other answer? The other answer that we had was negative 5 thirds. So we're going to check these answers by plugging them in here and plugging them in right here. So you got your calculator. So go to your calculator. I'm going to clear everything out of my calculator so we have a nice blank screen. To get to the absolute value bars, you're going to hit alpha window. You can see ABS. Press enter. All right. And then it has 8 plus p. So we already know what 8 plus 11 is, right? What is it? It's a total of 19. But if I do 2 times 11 minus 3, we also get 19. If you're wondering what I did, all I did was do what? Plug in an 11 right there. And what did we end up getting? These numbers match. So what does let us know about this number 11? It works. But what if I do, by the way, another way to get to the absolute value is hit the math button, go to the right where it says number, and hit enter for ABS. If I do 8 plus negative 5 divided by 3 and press enter, you get 6.3 repeating, so 6 1/3. But if I do 2 times negative 5 divided by 3 minus 3 and press enter, what do we get? Negative 6 1/3. Do these match? They don't match. So what answer works when we plug it in? The 11. This one works. Which answer doesn't work? That one right there. So what I want you guys to understand is sometimes you might solve everything perfectly, but an answer does not work. Now here's the definition of this negative 5/3. Could you please write this definition down? This is called an extraneous solution. It's called an extraneous solution. An extraneous solution is an answer where you did all the math correctly, you did all the algebra steps, you did everything right, but when you plug it in, it doesn't work. So the only answer for number 7, the only answer that we are going to put into the set is the number 11. Oops. Now, if you have Desmos, I want you to go to Desmos real quick. All right, we're going to show you kind of how cool Desmos is because it's awesome. And we're going to type, see where it says 8 plus p? We're going to take that, except we're going to change it. We're going to go here, hit the absolute value bars. We'll put 8, except we're going to put plus x, and we see the graph. Cool. And then instead of 2p minus 3, we're going to type in 2x minus 3. Now, can you guys see right here how many times is this going to cross? It's just going to cross how many times? Just once. And where's the only place that it crosses? At an 11. Okay? So it doesn't cross. It only crosses once. Well, where could we have like 2 answers? Well, look what happens if I decide to, I'm just going to move up the y-intercept a little bit. Okay? And then I'm going to change the slope to say like 1/4. Okay, so I'm going to zoom out now. Can everybody see now? Like if I had this absolute value expression equal to this linear function, do you see how many places it now crosses? It crosses twice. All right? So understand, sometimes what are you going to have? You're going to have only one solution, right? And sometimes you might have two solutions. Now, most absolute value equations, when you guys are having to solve, are just like you'll see y equals 6, and you'll clearly see where the two places are. Okay? So we're going to do one more of these. Actually, you know what? I think that's pretty much good enough. What we're going to do right now is we're going to go to the Khan Academy, and we're going to do one of their problems. All right? All right, so we're going to go down here to the Khan Academy. Ooh, I like it. Let's do this one. All right, so go ahead. Could you guys please put this bad mamma jamma in your journal? All right, I'm going to write this down a little bit bigger. So we got a 7, and we got these big old fat absolute value bars right here. And that says minus 10, so I'm going to put minus 10. Then there's the equal sign, so I'm going to put equals. And I think I'll change colors here. Make sure we know that's the equal sign right there. And then I got 5 times the absolute value of x minus 3. I'm going to close that sucker. I'm going to put minus a 10. Okay, like that. So go and write that down nice and neat. I'm sure you can do it neater than me. Now, we're going to kind of go over a concept right here. Right now, what if I said 2 plus 2? I think everybody would hopefully say 4, and you'd be like, okay, good. Now, if I say 2x plus 2x, what would that equal? 4 x's. All right? But what if I say 2 times the absolute value of x plus 2 times the absolute value of x? Using the same pattern, hopefully you see the pattern like, could that be 4 times the absolute value of x? Yes. Just like if I said, what is the square root of x plus the square root of x? How many square roots of x's do you have? You have 2 square roots of x. So what I want you guys to understand, here's the concept. If they're the same absolute values, you can add them together or you can take them away. So check this out. Does everybody see here we have what? 7 of these guys, right? Everybody see that? You have 7 of those. And over here, what do we have? 5 times the absolute value of x minus 3. So in your journal, what I want you guys to understand is these are like terms. So how could I get rid of a 5 times the absolute value of x minus 3? All I got to do is take it away on both sides. So I'm doing it nice and slow, so I'm not going too fast. So what is 5 times the absolute value of x minus 3? Take away 5 times the absolute value. What's going to happen? Those are going to what? Zero out. Well, how many am I going to have over here on the left-hand side? Yeah, that's right. I have 2 times the absolute value of x minus 3. Now I'm just going to bring down the minus 10. And right here, see that minus 10? I'm going to bring that down as well. There's my equal sign. Uh-oh. Interesting. Look at that. I got a negative 10 and a negative 10. So what happens when I add 10 to both sides? They totally cancel out. Wow, I'm getting a lot smaller now. I got 2 times the absolute value of x minus 3 equal to 0. Well, if I divide both sides by 2, 0 divided by 2 is still what? Still 0. Huh. Well, there's no, what I just got to find one number. What's the only number that you could plug in to this absolute value expression that's going to magically make it equal to 0? There's only one number. And that number is 3. Well, I thought we had to separate it. Well, what's the only number that's impervious to making it negative? or positive. 0, right? So I don't have to do the splitting of the equation. I just got to find, like, what number would you plug in to make it equal to 0? That number is 3. So that all that work, only 3 is going to work. And that's it. All right. So right now, we are going to do one more of these. All right, so here we go. Here's our second problem. We're going to write 7 times the absolute value of x minus 2 plus a 7 equals negative 2 times the absolute value of x minus 2 plus a 2. There's my equal sign, so that's something I got to be aware of. There's my equal sign. All right. Now, here's what I'm going to do. I'm going to search for my absolute value expressions, and there we go. There's one of them right here. And then I'm going to highlight my other one right here. There it is. So I have to make a decision. Do I want all my absolute value on the left or on the right? Well, I'm going to move them all to the left because I got 7 of them. All right, so how do we get this equal to 0? What would we have to do to both sides of the equal sign to get this equal to 0? That's right, we have to plus 2 times the absolute value of x minus 2 on this side, and we have to plus 2 times the absolute value of x minus 2 on this side. And what is that going to give us a total of? A total of 9 times the absolute value of x minus 2. Well, if I put all of my absolute value, which is this, I put all of this on one side, what do I got to do with my constant right here? I got to move them to the other side. So how do I get rid of a positive 7? What am I going to have to do? I'm going to have to take it away. So that zeroes out. I'm going to take it away right here. So what do I have left? I have 9 times the absolute value of x minus 2. 2 minus 7 is negative 5. Interesting. So I have 9 times the absolute value of x minus 2 equals a negative 5. Now, the next step algebraically, if you were going to do the next step algebraically, you would divide both sides by 9, and that would leave you with x minus 2 equals negative 5/9. This is what I'm hoping all my students will do at some point. Hopefully at some point they will look at this and they will just stop working. Like they will say, I don't have to work anymore. Because what's the smallest number? What's the smallest number that this could possibly equal? What's the smallest number? The smallest number is going to be 0. Will that ever equal a negative? No, it will never equal a negative. So listen, the absolute value of x, whatever that is, it will never equal a negative. Now what does that mean for us? That means there's going to be what? No solutions. Now, could you keep working? Like, here's what some students will do. Ready? They'll break it down. They'll say, okay, I'm just going to keep going. X minus 2 equals negative 5/9. And then I'm going to break it down over here. X minus 2 equals positive 5/9. And then they'll keep working and they'll solve for x. And they will get 2 extraneous solutions that will not work. So what do I want you guys to recognize? Whenever the absolute value expression right here equals a negative, what do I want you to do? Stop and just hit no solutions. All right, so how could you check graphically whether or not you have one solution or two solutions? We're going to go ahead and just show you in Desmos real quick. I'm going to clear this out. All right, I'm going to clear that out. I'm just going to look really quick. That says 7 times the absolute value of x minus 2 plus 7. Let's see if I can remember that. 7 times the absolute value of x minus 2, and then I'm going to put plus 7. So there's that one right there. And then I will look over here, and that says negative 2. Okay, times the absolute value minus 2. See where I remember that. Negative 2 times the absolute value of x minus 2. I think that's minus 2. All right. So you'll kind of see that these absolute value equations, like they don't even touch each other. All right. So if they don't touch each other, that means there's going to be no solutions. All right. So graphically, I want you to see why there would be no solutions. All right. Now we're going to go ahead and move on to the next question. All right. Here we go. Here's our final question that we're going to work on. We'll show you how to do it algebraically, and then we'll kind of check it in Desmos. Don't use Desmos just to get the answers, because that just means you're being lazy, and eventually your laziness will catch up to you, and you'll have to take a remedial math course that doesn't count, but you still have to pay for. So right now, here we go. I don't know about you, but I like to save my money and not spend it on frivolous courses that don't count. All right. Wow. We got a lot going on right here. There's my equal sign. Didn't do a very good job there. See if I can do a better job. All right. I think one of the funniest things is when I'm doing a problem and then a student will like ask me for help and we've actually done the exact same problem. It always cracks me up. All right, so I'm highlighting our absolute value expressions. Now, that one's negative, that one's positive. So since that one's negative and that one's positive, that kind of helps me make my decision. I'm going to go ahead and add 3 times the absolute value of x plus 10 on this side. I'm going to add 3 times the absolute value of x plus 10 on this side. So when I add these together, now these zero out, these are additive inverses, they zero out. I can add these together and I get a total of 5 times the absolute value of x plus 10. All right? Now if that says positive 12, I'm like, how do I get rid of a positive 12? Well, that's easy. You just take away 12 from both sides of the equal sign. And 62 minus 12, hopefully you know, is 50. All right, so let's see what we have left here. I've got 5 times the absolute value of x plus 10 equals 50. There we go. All right, let's go ahead and divide both sides by 5. Nice. That'll work. So here we go. The absolute value of x plus 10 equals 10. All right, so we got to find 2 answers. We got to find 2 answers that will work. All right, so what do I got to do? Now I'm going to separate it into 2 equations. Now this is kind of easy. You could probably do it in your head, but I'm going to go ahead and just do the process. We're going to say x plus 10 equals 10. And then we're going to put x plus 10 could also equal a negative 10. So whatever this expression could equal a positive 10 or a negative 10. So over here you could say, I know it's going to be a plus, and I also know it could be a minus. So there's the plus, there's the minus. Now we just have one step here for each of them. Hopefully you know 0 plus 10 is 10, but if you didn't, if you took away 10 from both sides, you get x equals a whole lot of nothing. And then over here, if you take away 10 from both sides, you get x equals negative 20. So I have a solution set. That's a horrible solution set bracket. Let's try it again. Oh, that's so much better. Negative 20. And my other answer is 0. So I have 2 answers, negative 20 and 0. So I'm feeling pretty confident that I'm going to choose answer choice B. But check this out. We're going to take this expression, this equation, and this side of the equation. We're going to put it in a Desmos so you can see the concept. All right, so here we go. Let's go and clear this out. Move this up. Take a look. It says 2 times the absolute value of x plus 10. And then it was plus 12. There we go. And then over here we had negative 3. It was also the absolute value of x plus 10. But then, hold on, wait for it, there was a what? Plus 62. All right. Now let's check this out. Oh, cool. Look at that. You see where they cross? Huh? They cross where? At negative 20 and they cross at 0. You see that? Pretty cool. Cross at negative 20 and 0. So wait a second. Are you telling me all I got to do is type it in and like see where they cross? Yes, but I don't want you to do that. I want you to do that to check your answer. Don't do it to just find the answer of 0 and negative 20. All right? Otherwise, you're just cheating yourself. All right? Just remember, it is better to fail with honor than to succeed by fraud. Have a wonderful day.